Okay, this is question 9. Have a go. Okay, now part 1 is really just a set piece question. So we go and let capital X equal 3x minus 15, and we go and change our boundaries accordingly. So the 0 and the 180, timesing them by 3 and taking away 15, we get these as our new maximums and minimums as our limits. So going back to our substitution, we're now going to solve sine capital X being a half. So x equals inverse sine a half, and using our calculator we get our first value as 30. Now, looking at the all silver toy cars, where are all the positive sign values between minus 15 and 525? Well, we get one at 30, we get our next one at 180, our next one at 390, and our last one at 510. They are our 4 limits within these boundaries. We've then got to convert back to little x. Now remember, just changing the subject, little x is capital X plus 15 over 3. So add 15 and divide all of these by 3 gives us these 4 solutions. Now for part 2, we really need to consider the movement from the normal sine curve through to the curve that we've been given. So for a normal sine curve, we would start off at 0, then we would go to pi, and then we would have 2 pi. But we haven't got 0, pi, and 2 pi. We've got a tenth pi, 3/5 pi, and 11/10 pi. So basically, we've really got a simultaneous equation here. We've got a times. So how do we get from here to here? So we're really saying we've got a times x. So a times pi over 10 minus b equals 0. And secondly, a times 3 pi over 5 minus b equals pi. We could even have had a third one doing it from here to here, but I've taken those first 2. So basically we've got these 2. Now if we call these 1 and 2, from 1 we can say b equals a times pi over 10, call this 3, substitute 3 into 2, then we get this here, multiply through, and we basically get 5a over 10 equals 1, so a is 2. Now once a is 2, we know that b from this third equation is just a times pi over 10. So given that a is 2, so b is just 2 pi over 10, which is pi over 5. Now that was quite tricky.